Hey, I'm Himanshu Sharma. I work as a full stack software engineer at Postman. In this video, we'll discuss about browser, like how browser actually parses your HTML and CSS, and how the JS interacts within the process, and like what is the DOM tree, how it constructs the render tree, and all sort of those things, and like finally how it paints your screen. So let's first start with browser components. So browser contains mainly these like around 7 components. So first of all, we have the UI layer. So the UI layer, or we can say the UI interface of the browser, it includes the address bar, the back and forward button, the bookmarking menu, etc. Like every part of the browser that display except the window where you see the requested page, like all of the region, that is like the tabs part and the add button and all sort of those things. So next, the browser engine actually marshals actions between the UI and the rendering engine. So the rendering engine is basically responsible for displaying the requested content, like your HTML and CSS. For example, like in this case, let's say the requested content is HTML. The rendering engine parses the HTML and CSS and displays the parsed content on the screen. So one of the example of the rendering engine is WebKit. So Mozilla Firefox, I think, uses WebKit, or I think Safari. Yep. The next is the networking part. So like the browser needs to make the network calls such as HTTP requests, that like like different browsers have like different implementations, but this is something, this layer is like platform independent. So it has a like platform independent user interface. Then we have UI backend, that is used for drawing basic widgets like maybe combo boxes and windows. This backend exposes a generic interface, and that is not platform specific. Underneath it uses operating system actually. So the next is JavaScript interpreter. So it use like it parses the JavaScript and like executes the JavaScript code. Then we have some data storage, data persistence storage. Like this is a persistence layer where browser can save all sort of data locally, such as cookies. Like there are other storage mechanisms like local storage, index, TPL, like file system. So also, it is important to note that browsers such as Chrome can run multiple instances of the rendering engine. Like each tab that you open in your Chrome or Firefox is actually an instance of the rendering engine, and each tab runs a separate or a new process in your computer, in your local machine. So yep. Let's start how it goes, how the process of displaying all those content in the browser goes, and what are the major things that the browser is doing in the back. Uh, so first of all, when you hit any address in your URL bar, in your address bar, and you hit the enter button, first of all, how the process goes is it tries to fetch the IP address of that particular website. Let's say you hit www.youtube.com. So the browser will try to get the IP address of this, because in the end servers are identified by their IP addresses, and this website is somewhere available in some server. So to get this IP address, the browser makes a DNS lookup. First of all, it checks it in its local cache. Let's say you are hitting this website for the first time in your browser. So the IP address won't be available in your browser cache, so it will have to go further. So then it goes to your router, like router also has a table which stores IP addresses of the websites which you have been like hitting. It has a cache mechanism there. Then it goes, if again it's not available there, it goes to your internet service provider. And again, if the IP address is not present there, then it will finally go to a place which is like a server, DNS lookup server, which contains all the IP addresses of all the websites in the world. Yes. So yeah, I mean that also has like a scaling mechanism. You would think how would that DNS lookup server would maintain such a big repository of websites. So again, it has a lot of things going on there that makes it quicker and like to get, at least for the famous websites like youtube.com or google.com. So yeah, so once you get the data, you get the IP address. Now the browser will try to establish a TCP connection with the server. So again, it's the basic TCP connection, like you must have read about it. So it's like a three-way handshake. So once the browser was able to make the connection, then it will on the behalf of the user, it will make a fetch call to the server to get the get the website data or whatever. So let's say in this case, you were opening youtube.com. It has some like youtube.com is a website. It tries to get the data. You will get, let's say, HTML in response. So now the browser will start passing the HTML. So let's go deep into that process. First of all, let me give you like a big overview of the entire process. So when you get the response from the server, you have the HTML, the CSS files, the JavaScript files. So the browser will try to pass the HTML and the CSS. Also, meanwhile it's doing this passing, the JavaScript is also like executed, and it can halt the passing of HTML and CSS. We'll dig about this in later part. Once it passes the HTML and CSS, the parts of HTML gives us DOM tree, and parts of CSS gives us CSS object model, like CSS OM tree. Now this render engine like takes both of these trees and it combines them actually and creates a render tree. Now once we have the render tree is basically a representation of your website or your web page. It contains all the necessary information that is required to paint your page basically. So it then goes through a layout process to determine where actually this particular node of the render tree has to be placed. Node is nothing but a rectangular box on screen, right? Then once it has that, then it goes into the final paint process, that is actually like painting the pixels on your screen. So yeah, let's start with the parsing HTML step. So first of all, HTML is very forgiving in nature. By this we mean, if you are maybe you might not have seen any error when you are trying to load an HTML in your browser. So HTML parser actually when passing it, it removes the errors. Let's say for example, in this case you had a p tag but you forgot to close the p tag. So the HTML parser will look for a closing p tag, and let's say it's passing it comes here, div tag at the open of div tag, and see that the close of p tag was nowhere available. So it will fix it and it will produce like a fixed output. So it tries to recover from the errors. So the parsing is not like a straightforward thing. By straightforward I mean like we cannot use parsers that are used for other languages, like there are top to bottom and bottom to top type of parsers. Simply those cannot be used. It has to sort of use a customized or a special kind of parser to fix all of this. This parsing process can be halted. We'll see how this happens. It does this speculative parsing. Speculative parsing is something that allows a browser to parse ahead uh, for the resources that it might need. So let's say when I said it can be halted, I mean when you are loading an HTML and let's say in the head somewhere you have a script tag. So now it wants to load that script. So it will try to get that script. First of all, one thing that I forgot to mention is preload scanner. So this is like an optimization that the browser does. That is, when the browser tries to build the DOM tree or it's like passing the HTML, CSS, this process actually occupies the main thread of the browser, and there will be a preload scanner which will be like a separate thread process. What it'll do is it will pass through the content available, the entire DOM, and it will try to request high priority resources like CSS, JavaScript, and web fonts. Meanwhile, the parser is parsing the HTML. So it's like an optimization. Like when the browser is passing the HTML, there is like there can be other things that might be fast. So in the meanwhile, the preload scanner will try to make a scan and look or find these type of things, and will try to download them meanwhile. So speculative parsing is something, let's say there was a script tag in your head component in your HTML. Now that JavaScript needs to be downloaded, loaded, and then executed. So let's say JavaScript was being executed. So this is being done in the main thread. So what browser does is it creates another thread, and it will what do you say? It will start parsing the rest of the HTML while the JavaScript is being executed. So this is like to again optimize and fasten the process. So if the JavaScript does modify the page, let's say if there was any modification that you made within your JavaScript, the entire thing that was passed by the browser in the separate thread will be wasted. Like it will be deleted, will be flushed out. So yeah, they can, the reasons why where the parser can stop the passing of the HTML is like script. Again, if there is a script tag, it will try to fetch the JavaScript, load it, and then execute it. There can be ways where you can actually make this script non-blocking. We'll discuss about that. Also, link and inline CSS can hold the passing of the HTML. So yeah, also the parsing process is re-entrant. We'll see in some time what re-entrant means here. So let's say you had this HTML, or maybe you had a very dirty HTML where things were not correct. You didn't close and p tag or something. So the parser will fix that, and it will produce sort of like this output. Now it will start parsing it. So parsing process actually it has sort of two um, uh, two components. So the parser divide the work between two components. First one is the lexer, the second one is the parser. I'll explain quickly what that means. The lexer, or famously called as tokenizer, is responsible for breaking the input into valid tokens. So let's say the HTML was being passed, and the HTML was passed to this lexer or tokenizer thing. So it will start reading the characters one by one. Now it tries to read, it sees this is an open tag, like an identifier for opening a tag. Now it knows that there must be a tag name, and then it will try to find for the tag close, and then it will, once it gets there, it will get this, yeah, we have this, like we have a div tag open and we have a div tag close. So on the high level it looks something like this. So you had bytes, like um, the browser, the response that you got maybe was like was in bytes. Now it will try to uh, decode this. So maybe you have the maybe you are using the UTF 8 decoder, so it will maybe decode in this format. So we get the characters of uh, the HTML. Now the tokenizer will start tok- creating tokens out of this HTML. So see, it saw this start tag of body, then it got the text hello, and then it got start tag for span and sort of that. So it will create all those things. It will create these tags and it will identify the nodes, and now later on it will try to connect these nodes and build the DOM tree. So um, yeah, so we had tokenizer here. So also this is a high level view on how the tokenizer works. This is a state diagram of the tokenizer. It consumes the data. If the data is like end of file identifier, terminates the process. Else it tries to consume the open tag identifier, then gets the tag name, then consumes the close tag identifier, again comes back to this same state. Again this process continues. If there is this like slash, it gets to know that this is like a closing tag uh, state, or closing tag open state, and then again continues with the same process. Cool. So this is all about the parsing process of the HTML. Now let's see about this reentrant thing that we talked about in the very beginning. So parsing process can be interrupted. If it gets the script, it will load and execute, and if there is there you do something like you are manipulating the document, like with document.write, what it will do, it will rewrite the DOM, and so the same process starts again. It starts fetching the tokenizer, constructing the tree, and then it goes into the same way. Cool. Now now let's talk about how a script affects the parsing process of the HTML. So let's say if the script is at the bottom, then the entire page, or the entire HTML will pass uninterrupted. It will be faster to render as it's not waiting for any uh, JavaScript to load or download. If we put if for some reason we cannot put the script tag at the very bottom, we can use different async attributes. uh, Let me explain what are these. These are boolean attributes. If the differ attribute is true, it says that the script is downloaded in parallel to the parsing of the page and executed after the entire page has finished the parsing, right? So uh, it will make the JavaScript download as a async process and won't stop the parsing of the HTML. Now, if the async attribute is set true, the script will download in the parallel to the parsing of the page and execute it as soon as it is available, right? So this is the only difference. The differ attribute will execute after the entire page has finished parsing. On the other hand, async will start async will interrupt the parsing and will execute the script once it's available. But both are sort of an performance optimization where they are not blocking the parsing of HTML until the JavaScript is downloaded. Cool. So that was mostly all about the parsing of HTML and HTML. There is one thing after. Uh, okay, so let's talk about the CSS parsing. So, like again, CSS uses. I mean, the browser uses CSS parsers. So there is this WebKit uh, which uses Flex and Bison parser generators to create parsers automatically from the CSS grammar files. So CSS file is parsed into a style sheet object. Each object contains the CSS rules, and CSS rule object contains the selector and declaration objects and other objects corresponding to the CSS grammar. It again has sort of its own way of um, passing the CSS. We can read more about on this in the MTN talks. So let's talk about the order of processing scripts and style sheets. So if we talk about the order of processing scripts, when all of this process is going on, the model of the web is synchronous. Authors expect scripts to be parsed and executed immediately when the parser reaches a script tag. So the passing of the document, the passing of the HTML has to be stopped until the script has been executed. So this I think we already talked about some time back. And to fix this blocking of HTML passing, we have different async attributes. Then we talked about speculative passing, where it's like an optimization where another thread is created for the browser, and it tries to pass the other um, HTML until the JavaScript is being executed in the main thread. So style sheets uh, have a different model. Conceptually, it seems that since style sheets don't change the DOM tree, there is no reason to wait for them and uh, stop the document passing. But there is an issue on this. Though of script asking like though script do ask for style information during the document of the parsing page, if the style is not loaded or parsed yet, the script will get the wrong answers. So let's say you are loading a page, and there is some selector which is trying to get some information about some style, and the parsing has not been completed, so it won't get the correct result, so there will be inconsistency. So this has caused a lot of problems, and it's like a very common issue. So different browsers like handle it differently. Firefox actually blocks all the scripts when there is a style sheet that is still being loaded and passed. WebKit blocks scripts only when they try to access certain style properties that may be affected by unloaded style sheets. So this is how the parsing of style sheets and execution of JavaScript go hand in hand, go all together. So yeah. So once all of this parsing is completed, we get the DOM and CSS object model from this step. The next step is generating the render tree. So render tree actually combines both of these DOM and CSS object model, and it is basically the actual representation of things or nodes, or by node here I mean the rectangular boxes that will appear on your screen. Also, it's not a one-to-one mapping of your HTML. Let me try to explain that. So you see, DOM is something like it has HTML tag, then head tag has something, then body tag has maybe a P or a div, and then goes on, right? When the CSS object model is created, for each node it would have some properties like on the body it has font size 16 pixel, for paragraph it has some special properties maybe, and again for image or span sort of. So the render I mean, generating the render tree is actually is like a combination of both of them. So you see, the term that we had here, we have sort of attached the CSS properties to that term tree. And also, if you see here, HTML tag is not present, and then head tag is not present. So these are it only contains the things that will be actually visible on the screen. So if you have anything, um, any node which is like hidden via display none, it won't be present in the DOM. Again, if by any JavaScript you manipulate it and try to make it display visible, it will, what do you say, again restart the process, and now it will create a new DOM. Okay. uh, So if you see, this is an overview of how the browser works, like the entire process. So we have HTML, uh, we have style sheets. Both of them are parsed by HTML parser and CSS parser. This process is parallel. Then we get a DOM tree, and here we get style rules and the CSS. I mean, it's basically the CSS object model. Then both of them are attached, and a render tree is created, and then we do the layout. I mean, then the browser does the layouting, painting, and then things appear on the display. So let me try to try to show you what a render uh, object looks like. I mean, what a node of a render tree looks like. So this is like a, what do you say, uh, like a node of your render tree. So Firefox calls the elements of a render tree as frames, but WebKit uses the term renderer or render object. So in this is like a class for the render object. Each each node in the render tree will be an instance of this class. So see, if you see, this is basically CSS. So everything that is being done, in the end, the computer or the compilers need to have a language to understand everything, and there we use C++. So see, this it has few properties. These are basically, if you see, this node is actually the DOM node. It's like a pointer to the DOM node. Then we have this render style, which is like computed styles of the DOM node. Then we have render layer. So basically, to put your node or your element or your box on the screen, you also need a property which is like maybe a z index or a position which is absolute. So they are like within your application or within your web page, you can create layers. This is exactly the same layer that we are talking about here. So it contains information about how the layout part, um, and then it can also contain few information about the line boxes, which is like handling the text, wrapping the text, or the font size, or sort of that. So yeah. Uh, the render object has the visual output of the DOM node. Yes, it has generic information where to sit in the web page and how can layout and paint. It contains all of the information. It can hold styles and computed metrics, all sort of those things. So basically, render tree is the exact representation of what would display on the screen. So now the next process is layout. So when the renderer is created and added to the tree, by renderer here we mean the render object, it does not have a position and a size. So these values needs to be calculated. For example, like HTML uses a flow based layout model, meaning that most of the time it is possible to compute the geometry in a single pass. Elements later that are like calculated in the flow typically do not affect the geometry of the elements that are like already calculated. So layout can proceed from left to right, or left to right, top to bottom throughout the document. So actually in this process, for each DOM node, it will start from here, right, from this corner, and will start putting the start calculating the um, position for the or the coordinates for these boxes or these nodes of render T to place in the entire screen. It has sort of what do you say, reference or wrapper to viewport, where it starts from the viewport and starts laying out the elements of this render T. So yeah, so the coordinate system is related to root of the frame. The top and left coordinates are used. I mean, this is where everything starts. So an overview of layout process. So layout process usually has like this pattern where the first step is the parent render determines its own width, right? Then parent goes over the child and place the child render. It like sets the x and y of the child render. So let's say um, you had a container, which is the outermost container in your web page. The browser will determine its width, and then this container contains some children. So now it will try to place those children inside the container, like it will set the x and y coordinates for this container. Then it will call the child layout if needed, like now it will ask the child layout to follow the same process, and once that is done, like it has no children, then the parent uses children's accumulative heights and heights of like margins and paddings to set its own height. So now parent is like trying to adjust its height after all of his children's are uh, like all of its children's layout is calculated. Yeah, so again, once this is done, if there is another parent, that parent of this container, that will try to adjust or calculate its height based on its children. So it's like a recursive process. Cool. And once everything is done, it will set its dirty bit to false. By dirty bit here we mean that if dirty bit is true, that means that the particular container or particular node is being calculated. I mean, its layout is being calculated. So yeah, uh, it is like a, I mean, the browser does a batch layout where it will do things in the batch. It will like intelligently batch the changes so that it won't have to compute the DOM tree again and again. So yep, so there is one performance insight that we can talk about. So like we said, the browser actually patches its operations intelligently. So we can do the same thing. For example, here in this example, which is like a bad example, the we are trying to get the calculate the div height. We are setting the style, I mean we're setting this height, and then we are calculating the div height of another, and again we are setting this. So instead we are doing like read write. Instead of this, we can batch them. We can do read and write. So it will boost the optimization, sorry, boost the performance. So cool, let's go further. This is all that we have. So now let's talk about painting. So now to paint, it will take the uh, um layers out of the render trees, like, and it will okay. So in painting stage, the render tree is traversed, and renderer's paint method is called. So I pasted this object, right? So now this paint method will be called with some paint info, and it will do what it will like display the content on the screen. Painting actually this step actually uses the UI infrastructure component of the browser that we talked in the very beginning, and it will start displaying things on the screen. So um, so if we talk about the painting order, like if you are if the browser is painting a block or like a box or a node, it how it does actually is it will um, first paint the background color, then the image, then the border, and then start painting its children. And once like all the children are done, it will then paint the outline. Again, it's like an incremental process. It creates layer from the render object, position the nodes, the transparency overflows, canvas, video, etc. Cool. It produces a bitmap for each layer, and this bitmap is actually uploaded to GPU as a texture. Earlier, this was like uploaded to CPU, but since GPUs are better in terms of handling these sort of computations, so now browsers use GPU to get the enhanced performance. Now these composites like this GPU composites the textures and turn that into a final image that will like update the pixels on the screen, and you'll see your painted website. Yep. So that is all about it. So uh, like this compositing step is basically when sections of the document are drawn in different layers. Overlapping each layer, compositing is necessary to ensure they are drawn to the screen in the right order and the content is rendered correctly. Yep, I think that's all we had for this topic. Thanks for watching.